1.5 Algebraic properties of limits and piecewise functions. From algebra, you all know x plus x is 2x. So with limits, the properties are pretty much identical. Limit as x approaches c of f of x plus f of x, that's just 2 times the limit as x approaches c of f of x. So example 1, do you see they give us a few table of values right here? The table above gives selected limits of the functions f and g. What's the limit as x approaches 1 of f of negative x plus g of x over 2? So you do all these limits within the parentheses here. So you kind of see like f of negative x, right? As x approaches 1, that's asking pretty much for the limit as like x goes to negative 1, because if you plug the x is equal to 1 in here, that becomes a negative 1 plus g of 1 over 2. So as x approaches negative 1 here, you see we use the value here 2. And the limit as x approaches 1 of g of x of 6 is equal to 6. So 6 over 2, which is equal to 2 plus 3, which is equal to 5. So example 2. The graph of the function f is shown on the right. What's the limit as x approaches 4 of f of x? So this is like what we call a composite function, a function within the function. So the first thing we do is find the limit of this inside piece. The limit as x approaches 4, the limit as x approaches 4 of f of x. See the limit as x approaches 4 right here is going to 1. So now we take that 1 and make that the new limit. Limit as x approaches 1 of f of x. You see how we kind of just got rid of one of those f's that way? We took the inside, limit as x approaches 4 is equal to 1, and that 1 is now used as our new limit, and we got rid of that f of x. So it's just another f of x remaining. And then this is just equal to limit as x approaches 1 here, a y value of negative 1. So that's your answer for example 2. Example 3. This looks scary, but it's not too bad. The table above gives selected values and limits of the functions f, g, and h. What is all this right here? So you see everything in here is like talking about the limit. So for all these here, you have to use the values for the limits. And you see as h of 5 is just on the outside, so you use that by itself. So limit as x approaches 5 of h of x is 5. Limit as x approaches 5 of f of x, because this is a big parentheses, the limit's referring to all of this. Limit as x approaches 5 of f of x is 6. Plus 2 times limit as x approaches 5 of g of x is negative 1. Minus h of 5, which is 3. So that's a 5 times 6 minus 2, which is 4. Because 2 times negative 1 is negative 2. 6 minus 2 is 4. Minus 3, that's 20 minus 3. Your answer is 17 right there. Last one right here. So, piecewise functions. So again, this is a good practice with graphs, tables, and some more algebraic functions. You're going to be seeing a lot of these. This will help you get better with all of these different formats, modes of representation. So we have a piecewise function here. If you haven't seen these before, what this means is whenever your input is less than negative 5, your x input is less than negative 5, you plug it into the top. If your input is ever negative 5 or greater, you plug it into the bottom. So, part A, limit as x approaches negative 5 from the left. So we're talking about values less than, a little less than negative 5. We want to plug in that -5 into this top one because this is for x values less than -5. This is the limit approaching from the left, so we plug it in here. So if you do, I'm going to just do this on the side here. That would be square root of 11 minus -5, which is just plus 5. That's square root of 16, and that gets us a 4. Over here, limit as x approaches -5 from the right. Values a little greater than -5, so we plug the -5 into this bottom function here because it's for inputs greater than or equal to -5. I'm going to do this right over here. That will be -5 plus 3 over 5 minus -5 squared. That's a -2 over -20. That will give you 1 over 10. If you had confusions on how we got 1 over 10, I skipped some steps there. You can try that on your own. If you have trouble getting to that answer, ask your teacher, they can assist you. So, the left-hand limit is 4, the right-hand limit is 1 over 10. Therefore, the general limit does not exist because the left-hand limit is not the same as the right-hand limit. Let's go to this question here. G of x is equal to a 3-part piecewise function. X values less than -1, this top one. X values less than or equal to e and greater than -1, your middle one, and then x values greater than e is this bottom one here. So e is Euler's number. It's a constant that's approximately 2.7. So limit as x approaches -1. They don't ask for the left or the right, they ask for the general limit. So what we had to do here is plug in -1 to the top function and the middle function because the top function is the left-hand limit and plugging into the middle function is technically the right-hand limit because its x value is greater than -1. So if we just kind of plug them in here, let's see. Well, if you plug in -1 into the top function, you get a 3 because square root of 10 minus -1 squared, that's just square root of 9, which is 3. That's the right-hand limit. And then this is the left-hand limit. For the right-hand limit, you plug into the top one here. 26 minus 5x squared, which is 21 over 7. That's also 3. So this limit here is a 3. You can show your work, practice with how you got this. Again, if you're confused, please let your teacher know. They can support you. It's very important for you to understand these every step of the way, otherwise it'll hurt you later on. So part B, limit as x approaches e from the right of g of x. So e from the right, its x value is greater than e, so we're plugging e into this last function right here. That's going to be just ln of e cubed. Just plug in the e for x. And if you recall from Algebra 2 or pre-calc, this is just equal to 3. Limit as x approaches e of g of x. So this is our right-hand limit. Let's find our left-hand limit. So we have to plug in, so for our left-hand limit, if we plug e in here, that's a 26 minus 5e squared all over 7. And that is not the same as 3. So the left-hand limit is not equal to the right-hand limit, so therefore does not exist. Any questions for clarification, please, please, please ask your teacher, ask a classmate who can help you. Thank you.